Hello, good people of the SST. Today we're going to be talking about series and parallel circuits. So to start off, I built this circuit that we could study together. It has two light bulbs that are connected by some switches and a wire and a battery. And so what I want to first do is I want to call your attention to this switch right here. And I'm going to ask you what happens when we close this switch. Do you think electricity will flow all throughout here? Or do you think electricity will flow through this smaller circle? Or do you think nothing will happen since we have a break right here? So take a second, go ahead and pause the video for as long as you need to figure out where the electricity is going to flow when we shut that gate. All right, hopefully you've thought about it. So what we're going to do here is we're going to close this gate and see what happens, right? And so, surprisingly, it doesn't flow through all of here. It just flows through this small loop right here, right? And we can see, we can actually measure the current, and we have 0.9 amps, right? And so we're going to have a certain measure of brightness there. And so now that we have some current flowing, you can see we have electrons moving through the filament in the light bulb that's causing it to be brighter. But now, so this is a series circuit because we have the light in the middle of the series right there. But I want to ask you, what happens when we actually close this latch and we add another light bulb into this process? This is going to make from a series circuit into a parallel circuit. So take a second, use kind of the practice problems we did earlier to try to figure out what's going to happen when we switch this latch. Do you think this light bulb is going to be as bright as this light bulb right here? All right, go ahead and have your answer in your head. Here we go. So if we close this light bulb, you can see this light bulb didn't get any dimmer, and this one actually got the same brightness. And so if we double check that, we can see they're both the same size. And we can actually check that empirically by using this ammeter. So brightness is a measure of how much current is moving through a light bulb. And so if we put this little target right here, we can see that we have 0.9 amps right here, and then 0.9 amps right here. And so where did all that extra current come from, right? Because we've split our current in half. Well, if we look at our battery right here, we can see we actually have 0.18 amps of current. That's then getting split into 0.9 amps and 0.9 amps right here. Whereas before, we only had 0.9 amps of current through each of these points. And I know that sounds like a lot to keep track of, and we'll keep practicing this, but I really want you to take away from this lesson is that when you divide things in parallel, when you give electrons a different way to move through, they'll move faster because they like taking the path of least resistance. And so here the electrons are moving at the same speed and they're powering two light bulbs because they have two ways to get to those light bulbs. Whereas before, all those electrons were stuck moving through just this light bulb and going through all that resistance right there. So hopefully that makes sense. If you have any questions, please reach out to your mentor teachers. As always, thank you for joining me. Have a good rest of your day.